Please pause the video and read the question carefully. As we can see, the target here is determining the molecular formula of our hydrocarbon. And since we're dealing with hydrocarbon, it means that we're dealing with hydrogen and carbon only. So let's just represent these reactions in terms of equations and just do what we have to do. Since we don't know the number of hydrogen and carbon, so at this point we have to make, let's say, represent them in terms of variables like x, y, whatever you like. So let's start with CX, H, Y. It reacts with oxygen. The products are carbon dioxide and water. If you want to make a balancing for this, we can say that the number of X here represents the number of carbons, and if we multiply it here by X, actually X represents the number of carbon atoms. And if you look at Y here, how can I do the balancing for water? As we can see, we can represent it by Y over 2. But why did we do this? We just need to have the same number of hydrogen, which is Y, right? So if you put the fraction of Y over 2, we can represent these two cancel out each other, and then the value of hydrogen atoms are equal to Y. As we can see, the given information here are 0.2 moles for this hydrocarbon, which is unknown to me. And for carbon dioxide, the amount produced is equal to 35.2 grams. And for water, it's 14.4 grams. Okay. So if you just look at how can I determine the formula of carbons, if we determine the value of Y and the value of X at this point here, we can determine that molecular formula. And if we just go to the products, as we can see, if we determine the number of moles for here, actually we can determine the number of hydrogen atoms and carbon atoms. If we just make a simple ratio, we can change the grams of water into moles by dividing them over their molar masses. And the same thing here for carbon dioxide divided over 44. And if we just do this process, you will have 0.8 mole. And the same thing here, we have 0.80 mole of CO2. So how can I work out this one here? We want to divide this questions into two sections, and we start doing the first one here. If we just make a mole ratio in here, we can say that we have 1 mole of CX, HY. It's 1 mole, from the equation here. If we have 1 mole of CX, HY, it needs X CO2 to react. How many moles of CO2 we have here? We have 0.8. So here we have 0.8. And then we put how many moles of CXHY, as we can see, it's just 0.2. And if we just do some math in here, you can see that the value of X is equal to 0.8 divided over 0.2. And actually it equals to 4. And at this point, we can determine that carbon atoms are equal to 4. We didn't finish. Let's go again. We can say the same ratio, which is 1 mole of CXHY is equal to Y over 2 of water. And as we can see, we have 0.8 moles of water, and here we have 0.2. And if we just make multiplications and stuff in math here, we can say that Y over 2 is multiplied by 0.2 equals to 0.8 multiplied by 1. And as we can see, Y times 0.1 equals to 0.8. We divide over 0.1, 0.1, and then Y equals to 8. So at this point, we can say that the number of carbon atoms are equal to 4 and the number of hydrogen atoms are equal to 8. And this is actually the answer.